Now, in this session, we will talk about the maximum height, time of flight and range for this projectile motion, which we discussed in the previous class. So, this range can be written as, to simplify it, 2 times sine theta cosine theta becomes sine 2 theta. That is V naught square sine 2 theta over G. So you can write either this or this. Remember, this is 2 times sine theta cosine theta. This simplification in trigonometrical identities, it becomes sine of 2 theta. So the height, time of flight, range depends on two quantities. Velocity, initial projection velocity. This is called initial projection velocity. And the angle of projection theta. Okay. So the range is maximum when sine 2 theta is 1. That is, if I have a velocity v naught, constant velocity, so if I keep throwing that at same velocity but different angles, when do I get this range maximum? That is when sine 2 theta is equal to 1. So when sine 2 theta is equal to 1, we get R is maximum, which is equal to V naught square over G. That's the maximum value of range, R max. But when can sine 2 theta be equal to 1? It will be when theta is equal to 45 degrees. How do I know? If I put 45 here, 45 times 2 is 90 degrees. Sine 90 is 1. The maximum value sine can attain is 1. Therefore, at 45 degrees, we have maximum range. Okay? Do I have a maximum height? Yes, when sine theta is 1, that is theta is 90 degrees, that is when you project vertically, that's the maximum height. So, but we are not talking about one-dimensional motion, we are talking about two-dimensional motion. So, therefore, we don't have h value to have a maximum value for a particular theta. So, it keeps increasing, decreasing, so that's what it happens here. So, now the time of flight is 2v naught sine theta over g, and time of flight will be maximum when sine theta is maximum. And sine theta maximum when theta is 90 degrees. Again, 90 means vertical motion. So that we are now going to discuss, because we are going to discuss about two-dimensional motion, upwards and horizontal, both. So therefore, we have a maximum range when theta is equal to 45 degrees. So this is how you deal with this motion. And now, what questions can be asked on this projectile motion? So they can ask you to find height, time of flight and range. Apart from that, they can ask you to find the velocity v1 at some instant of time, which we discussed already in the previous session, that the velocity vx at any instant is v naught cosine theta. It doesn't change, it's always constant. But vy keeps changing with time. Which we specified in previous class. So these two are the velocities at some instant of time t. This is independent of time t because it's constant, and this varies with time t. So this is how about the horizontal velocities at any instant of time. Similarly, the vertical displacement at any instant of time y is given as v naught sine theta times t minus half gt squared. This is S is equal to V initial times T plus half a t squared. That's the same formula. Similarly, X is equal to V naught cosine theta times T. This is about the two-dimensional motion of a projectile. We can do a number of problems based on these all equations. We will meet in the next session with the problem.